Silence doesn't usually follow the word nuclear, but this time it did. On December 16, something quietly monumental happened in the American energy landscape. No countdown clocks on cable news, no breaking banners, no viral clips, just a shipment, sealed, regulated, and precise, leaving its origin and heading toward Idaho. Inside it were the first Aalo Zero nuclear modules. Not a concept, not a rendering, not a promise, real hardware. And from that moment forward, the clock officially started ticking toward one of the most ambitious deadlines in modern nuclear history. July 4, 2026, the day Aalo Atomics plans to reach criticality. That single shipment transformed Aalo from a startup with bold slides into a company racing against physics, regulation, and time itself. And if you think this is just another energy story, stay with me, because what's unfolding here could quietly redefine how nuclear power is built, shipped, and deployed across the world. What makes the December 16 shipment so important isn't just that parts move from point A to point B, it's what those parts represent. The Aalo Zero modules are the physical foundation of a factory-built nuclear reactor system designed to be assembled with the kind of repeatability you expect from aerospace, not traditional nuclear construction. For decades, nuclear power has been trapped by a brutal paradox. It's clean, reliable, and dense, yet painfully slow and expensive to build. Aalo's entire thesis is that this problem isn't nuclear, it's construction. So instead of building massive reactors on site over 10 or 15 years, they build smaller standardized modules off-site, ship them like industrial equipment, and assemble them quickly. That December shipment was proof that the theory survived reality. Steel, fuel channels, shielding, systems, designed, fabricated, inspected, and cleared for transport. At that moment, Aalo crossed the invisible line from we plan to into we are. And Idaho isn't just a random destination. The modules were shipped to one of the most strategically significant nuclear testing grounds in the United States. Idaho has been the birthplace of dozens of reactor experiments since the early days of nuclear power. It's where first-of-a-kind systems go to either prove themselves or fail in full view of regulators, engineers, and history. By choosing Idaho, Aalo didn't take the easy route. They chose scrutiny. They chose transparency. They chose the place where excuses don't survive data. This matters because the nuclear industry doesn't forgive hype. You don't get second chances with neutrons. Either your system behaves exactly as modeled, or it doesn't. And now Aalo's models are about to be tested in the real world. Here's where the timeline becomes intense. July 4th, 2026 isn't a marketing date. It's a technical one. Criticality, the moment a nuclear reactor sustains a controlled chain reaction, isn't symbolic. It's binary. You either reach it or you don't. And everything between December 16th and that date is a tightly choreographed sequence of engineering, licensing, installation, and validation steps. Every weld matters. Every sensor matters. Every delay compounds. The countdown isn't just about speed, it's about precision under pressure. Nuclear timelines don't slip quietly. When they slip, they do so publicly and expensively, which means Aalo has just committed itself to one of the most unforgiving schedules in modern energy development. Pause for a second and think about that. Most energy projects announce timelines knowing they'll slip. Nuclear projects almost expect it, yet Aalo is staking credibility on a specific date tied to national symbolism and scientific finality. That's not bravado. That's confidence backed by preparation. And it tells you something crucial. These modules weren't rushed. They were planned years in advance, designed with shipping in mind, built to interfaces that already assume future replication. This isn't a one-off science experiment. It's a prototype for a production line. Now let's talk about why this matters beyond Aalo itself. The nuclear industry is standing at a crossroads. On one side, you have aging reactors providing massive amounts of carbon-free energy, but facing retirement. On the other, you have exploding demand from AI data centers, electrification, and industrial reshoring. Solar and wind help, but they don't run smelters, chip fabs, or server farms at scale without massive storage. Something has to fill that gap. Small modular reactors, SMRs, have been talked about for years as the answer. But talk doesn't power grids. Hardware does. And Aalo's shipment was one of the rare moments when the SMR conversation moved from panels and policy papers into steel and shipping manifests. If you're still watching at this point, here's the real question you should be asking yourself. Why hasn't this happened sooner? The technology isn't new. The physics are well understood. The bottleneck has always been execution. Traditional nuclear projects behave like bespoke megastructures, custom designs, custom supply chains, custom everything. Aalo is betting that nuclear should behave more like aviation or semiconductors. Standardized designs, learning curves, economies of repetition. The Aalo Zero isn't meant to be perfect. It's meant to be the first iteration that proves the system works end to end. From factory floor to criticality, from shipping crate to neutron flux. And here's where the pressure intensifies. Once modules arrive in Idaho, the clock doesn't slow down, it speeds up. Installation begins. Systems integration follows. Instrumentation checks. Regulatory milestones. Fuel loading protocols. Every step requires coordination between engineers, operators, inspectors, and federal oversight bodies. This isn't a startup sprint, it's a marathon run at sprint speed. The July 4th deadline looms over every meeting, every report, every torque wrench. And unlike software, you can't patch nuclear systems after launch. Everything must be right the first time. Another layer to this story is what Aalo Zero represents strategically. This isn't a commercial power plant designed to light up cities. It's a test bed, a proving ground, a controlled environment where assumptions meet reality. And that's critical because the future reactors, the ones utilities might actually deploy, will inherit everything learned here. If Aalo Zero performs as expected, it validates not just one reactor, but an entire deployment philosophy. If it stumbles, the lessons still shape the next design. Either way, this module shipment marks the beginning of feedback loops the nuclear industry has been missing for decades. And don't underestimate the symbolism of July 4th. Choosing that date wasn't accidental. It frames nuclear energy not as a relic of Cold War thinking, but as a modern pillar of independence. Energy independence, industrial independence, technological independence. A reactor achieving criticality on Independence Day sends a message. This is about domestic capability, domestic manufacturing, and domestic resilience. In an era of fragile supply chains and geopolitical energy shocks, that message matters. At this point, you might be wondering, what could derail this? And that's a fair question. Nuclear projects face three enemies: regulation, supply chains, and reality. Any one of them can introduce delays. But the fact that the modules have already shipped eliminates a huge portion of uncertainty. Manufacturing risk is no longer theoretical. Transport risk has been cleared. What remains is execution. And execution is where disciplined teams separate themselves from ambitious slide decks. Here's another engagement moment, because this is important. If you're someone who's followed nuclear news for years and grown cynical, this story challenges that cynicism. It doesn't promise miracles. It promises process. And in engineering, process is power. The December shipment wasn't loud because it didn't need to be. Confidence doesn't shout, it ships. As we move closer to 2026, expect the narrative to change. Right now, this is an insider story. Engineers, policymakers, energy analysts, But once fuel loading begins, once systems go live, once criticality approaches, attention will follow. Because success here doesn't just validate Aalo, it pressures every other SMR developer. It forces regulators to adapt. It gives utilities a real data point instead of another feasibility study. And there's a deeper implication most people miss. If nuclear modules can be built, shipped, and commissioned on predictable timelines, the entire economics of clean energy shifts. Nuclear stops being the slowest option and starts becoming the most dependable one, not in theory, but in practice. That's why this shipment matters far beyond Idaho. So as the countdown continues, day by day, checklist by checklist, remember this: revolutions don't always arrive with explosions. Sometimes they arrive on trucks, under escort, with paperwork thicker than steel. December 16th wasn't the end of a process. It was the beginning of accountability. And July 4th, 2026 isn't just a date. It's a test of whether nuclear power can finally step into a faster, smarter future. Stay curious, because the quiet stories are often the ones that change everything.